This is the last part of section 4.4, and this is about extrema, or relative maximums and relative minimums. Those are turning points on a graph. In particular, they're the highest point in one area or the lowest point in one area. They're not truly the highest point, because that would be positive infinity or negative infinity for the minimum, for the real lowest. But in this area, it comes up to a stopping point, or not a stopping point, it comes up to a highest point and then goes back down. So that point, the highest they got to there, is relative to that area, just that part. And down here, relative to that part. So it looks like there is a relative maximum at that point, which is at -1 and 5 for the y. And at this point, which is 7 for the x and -4 for the y. Increase that a little bit so you can see the graph. So this would be considered the relative maximum, and this would be considered the relative minimum. So graphically, you can see what it looks like, and you can identify them. You can also identify them through a table of values. And that's what I'm going to show you how to do. And that's a skill you need to do. You need to be able to put down a table of values and identify the relative maximums and minimums from that. Now, one thing to remember is this kind of a curve. This is an x cubed. It hits the x-axis in 3 places, and it has 2 curves in it. So if the polynomial you're given is x cubed, that means you know that because it has an exponent of 3, it's going to have 2 curves in it, so it should have one maximum and one minimum, or one relative maximum and one relative minimum, as well as 3 solutions to it. Now, let's come here. -4 is way down. -3 here is just at about 0, but it's a little bit past it. It's like maybe it is y is 0. And -2 is at maybe about 3. -1 is 5. At 0, we're at about 4.5 or so. 1 is at about 4. 2 is at about 3. 3 is just at about 1. 4 is at maybe about -2. 5 is at about -3. 6 is at, looks like maybe -3.5, and then 7 is at -4. And then at 8 comes up a little bit, looks like it's at about -3, and 9 is at about -2. Now let's analyze this data that we got from the graph. Look at what's happening with the y values. Going up from 0 to 3 to 5, and then we start going down. So it's like here at this point, we're going on an upward scale. So sort of like 0 to 3 to 5 is this, and then 4.5, 4, 3, going down like that. And the top, the pinnacle of it is 5. So from here, you're going to 5, and then it looks like you were going to 5 this way. So this here is a relative maximum. And you would go over here to get the x value, and you would say -1.5 is a relative maximum. Now when we keep going, we say we're going down, down, going lower, going lower, going lower, going lower, going lower, and then start going up again. So when you see here, we're going down to where the 4 is, but then we start going up again. So that means I was coming the other way. I was going down to the -4. Going down, and I'm going down to it. So you think of it as going that way and going that way, and these two meet there. But you can see it here because the numbers get smaller, and then they start getting larger. The point that's the lowest one would be 7, -4, and that would be my relative minimum. So we have a relative maximum and a relative minimum that you can tell based on the numbers on both sides of it. But you have to be aware of what they mean. You're getting larger, and then you start getting smaller. The place where you change is probably the relative maximum. And here, you're going lower, then you start going up. That means that the place that was the smallest is your relative minimum. This is what you need to be able to show me so that you can state that this is a relative maximum or relative minimum. You can graph something as well if you want to, but you don't. It's not I don't mind if you were to do that, but this is what I must see when I say make a table of values, and from it, show that you know where a relative maximum and relative minimum are. Now, to help you with making a table of values, let's do it on the graphing calculator, and let's see how to find a table of values, because there is a place right there above graph where you can see a table for a graph. So let's say, and here's one where I was working on it, let's go back to here. This is a polynomial, x cubed minus 2x squared minus x plus 1. So if I were to give you this, you can graph it, and that's what the graph looks like. And you can see, oh, it looks like there's a relative maximum here and relative minimum here. You can even tell with the trace where they are exactly. If you hit trace, you can move along here and watch as the x value goes up to 1.54536170. And what happens to the y's? When we're back here, negative 1.2, 1.4, negative 1.5, negative 1.6, still 0.6, and then it goes down. Notice that here we're going from 0.604, 0.63, 0.61. So if I go back, this is pretty much the lowest point there. So the x is about 1.5. Now, let's look at it as a table, though, because I require you to do a table. You don't normally need to do that if it's at a more of a point. If I do second and table, I have here 0, 1, all of these. Notice between 1 and 2 that they're both negative 1. And go back to the graph. That's because at 1, I need a better point. Yeah, it works. At 1, we're at negative 1, and at 2, we're at negative 1. So that means the curve went a little lower. So I have to use the trace to figure out or approximate where it is. Or I could have put 1.5 into the calculator and figured out what the number is there, because that would have made sense. That would be right in the middle of 1 and 2. But back over here now, I need to see what this one is. And when I go to the table, I have 0 as the starting one, so I can go back here, and I can see, we're at negative 41, negative 13, negative 1, 1. So it looks like 1's the highest point. 0, 1 would count as the relative maximum. And that's an approximation. If I go back here to the table, I can see with the tracing of it that it's really not quite 0, it's a little bit before it. So at negative 0.1, and then I see these numbers, 1.1, 1.1, wow. We are at this one. It looks like the highest point is at 0.25. So at about 0.25, or it's 0.26, that's where the x is, negative 0.26 and 1.1. Well, that's very, very close. You can't always easily see it. That would count. That would be better to do. But if you use a table, you can do that. Use the table and do the approximate relative maximum as 0, 1. Farther down here, when you see that these two are the same for the lowest point, you're going to have to do the middle and figure out what that was in between. You can change the numbers here. Let's look at table set. And so what I'm going to do here is I'm going to try to do it as second table set. It's starting at negative 3, which is where that screen was a moment ago. I could change that if I wanted to. In fact, I think I'll make it negative 2. And right now the table has a scale of 1, so it's using every single number. I'm going to go to 0.5, so it uses the halves in between as well. Now when I come to here, okay, negative 2, negative 1.5, negative 1, negative 0.5. This still shows that we're closer to 0, 1, so we can use that. But when we go here to 0.5, then 1, and now you can see that at 1 you're at negative 1, at 2 you're at negative 1, and in between, that's a better minimum value, 1.5 and negative 1.625. Now you can see the usefulness of the table. So when you have a graph of a curve, like that one is now, you can see the points on it by doing second table. And you can use table set to either go by integers or by decimals in between the integers. And that can help you a great deal in making a table like this, so that you can better determine what the relative maximum and relative minimum are. You can use it for other things as well. So if you need to make a table and you correctly put the function here, then you can use second and table and adjust it as you might want to with second and table set to be able to get the y values. Especially now, let's go back to ones here. Many times that's going to be most helpful, because then you can graph something yourself or identify something. But this case showed me I needed to get a little more detailed into it. Okay. Hopefully that helps to understand and be able to find relative maximum and relative minimum, or find extrema. And you have to be able to make a table and show it on the table. You can use a calculator to help you, but you have to be able to write that down. Okay. Thank you for watching.